Hi guys, this is Jawad, working late from the office this time and recording also from there. And with this little different setting, I had a small request from my daughters, very young daughters, to wear these on my next video because that would make it more interesting. So that feedback has been taken. Thank you, Jamie, and thank you, Melek. And there was some more feedback about the resolution. Apparently, the resolution was too high because I was recording at 4K, and not all laptops support that, including my wife's. And she asked me to lower the resolution and enlarge the writing on the screen so that everybody can read the code easily. So thank you everybody for the feedback. Today we're gonna talk about reducing the complexity, the code complexity as usual, but the method we're going to be using is abstraction using frameworks and generic code. So this method of reducing the code complexity is the last one actually in the series. So let's talk about what we're going to talk about today, what's on the agenda. Well, we're going to go through quickly what we have already covered, and then we're going to go through to talking about the reduction of code complexity using frameworks and why, and then explain through an example what you can achieve in a bit of code as we are used to. So we have already talked about refactoring tools and strategies using displacement and abstraction. Displacement is basically we did one context, and that is displacement by responsibility. You can do it in other contexts such as architecture and more. And we talked about abstraction and different strategies for that. So we talked about polymorphism, done some examples there, and functional programming and built-in libraries. And today our focus will be a bit different. So when we have complex code and we are doing some standard stuff, the chances are big that there are people that have already thought about the problem and created the solutions in the form of a library, a framework, generic code, you name it. Example code on the internet. There are many ways that you can use these strategies to lower your own code complexity. Of course, it has its own merit and its own usages, and so let's go through a few aspects that you should consider when you take this approach or strategy. So, of course, before you start refactoring, you make sure that you have the checklist done that we have covered before, so I'm not going to cover it again. But when you are going to use frameworks or generic code libraries to reduce your own code complexity, you should consider the next. If you're going to choose somebody else's code, then it's would be nice that it has an active community supporting it. Maybe you're part of that community. That would be even more wonderful. Contributing is wonderful always. So yeah, an active community. It's the code is being maintained. It's being widely used. That means a lot of people have experience with it. It's well documented. So if like after a year, if you want to change something, you should be able to fall back to documentation or community if you want to, and that it has no vulnerabilities that you are introducing into your own code by importing those libraries, which is which is always a thing to consider as well. So well maintainable, active community, well documented, ease of implementation, of course. When you're using a framework, it should decrease your own the complexity of your own code, not make it more complex. So yeah, these are things that you should consider when you're using a different framework to solve an existing problem. The demo today, I'm going to do it a bit differently. Normally I would start typing and create a solution on the fly. Seeing that this approach actually is more about learning how to implement somebody else's framework or third-party library. Really, it's not about the ease of coding. It's more about the ease of research and getting to know a different library's benefits to your own code. So instead of that, I did create the code to show the benefits, and we're going to go through the code that has the complexity problem, and then we're going to go to a possible solution. Of course, you can solve it in so many ways, so it might not even be the best solution, but it will be an indication of what you can do with somebody else's code, right? And what it can mean to the readability of your own code. So let's go. I'm gonna get the code, and this is the solution. We need the problem. Get the problem. Okay, so I'm going to build it really quickly, just to make sure that I didn't mess up anything locally, and then go through the application as you see it here. It's not very big. It is a CSV reader. So let's say you have a comma separated file, an export of an Excel sheet or whatever, but you have a comma separated values file with persons in it, and you need to convert those values into actual Java objects that you can reuse in your application. So to do this, this is actually very common. A lot of companies still use it, a lot of developers still program it, and I have been through the same mistake like twice, and thinking, oh, this is easy, I'm just gonna write it by hand. And then somebody adds a column or change the date format, and then the code gets complex really quickly. So what do we have here? We have an application. It gets arguments, and in those arguments there is one file name. So if we have this file name, then we're going to pass it through, we'll log some information and then pass it through to the person controller that is going to be handling the next step. So the person controller, didn't finish all the way. The person controller, when it's done, is going to return a person's list if it did its work correctly, and that list will be logged as well. So the person controller will not be doing a lot by itself. It's just going to check if the input is well. So if there is a person's comma separated file, and if it is good enough to pass through to the service that's going to do the actual reading. So the person CSV service is going to get that file name and try to read it. So a bit of complexity going to start there, and a bit of unclean, a bit harder to read code. So what it does, it gets the file and it creates an empty list, person list, and it's going to check if the file exists, then creates a buffered reader, uses that buffered reader to read the file line by line, basically. What it is going to do though, it's going to check if the first line has been passed. So there's a line counter there, gonna check if going to increase every time. So as long as the first line is skipped, then it's going to start mapping persons by using a mapper. And that mapper is implementing a function that does something very simple. So there's a function, it gets a string, maps it into a person. So this line is going to be split by commas, and we're going for just the simple normal comma. And then we know, and we have hard coded that the position 0 after that in the array that is being created, after splitting the line into an array, the first position is the name, second is the birth date, and the hair color is the third. If we know these three, then we're going to put them into a person through a constructor. If we go to the person, then I was actually expecting to see some complexity. So this class has a complexity of 11, and I was hoping to see that. I'm going to rebuild the project. Hopefully it will show the complexity next time it opens. So I'm going to close it, close it, close it, close everything, close all tabs. It's finished. Oh, okay. So it has a complexity of 12 because it does some checking and some illegal argument exception throwing. If the name is empty, or the birth date is empty, or the hair color is null, for example. So it does some kind of validations here. It has some getters, and it does a toString in a specific manner, so it would print the object in an object readable manner, kind of. So it does all these things. So the complexity is really here in this class mostly, and in the service secondly. But the thing is, I hate to see so many if, else, try, catch, while loops inside of it. It doesn't make for beautiful readable code. Also, reading comma separated values is so, as old as my grandmother, God bless her soul. Probably not, but anyhow, it is very old. We've been doing it since the computers maybe had been created. So comma separated files and inputting data from CSV files, it's very old. So the wheel, I'm sure, has been invented so many times I can just reuse it, and that's what we did. So to solve this problem, I decided to go and look for some possible frameworks that can help me. And so I just did a quick search, and I said like Java, CSV, reader, mapper, options. Google it, and well, MyCon gives you some info. Reading CSV with Jackson, and then they'll, if you say Java CSV reading frameworks, let's see, then it will give you like, oh, what kind of libraries, and you stumble onto OpenCSV, you stumble also onto Apache POI, you stumble again across Super CSV, and then you go into reading what this. I even tried ChatGPT to make a comparison just for the fun of it, but to be short and not to take too long of your time, I just opted for one that seemed to be simple, which is the OpenCSV. It has also a bean mapper, which seemed to be a good fit, And so I implemented the OpenCSV, and I didn't want to do too many validations by myself, so I used a out-of-the-box validation from Java, implemented it in with an auto-wiring framework, and used Lombok framework to reduce some of the boilerplate. So the result is, I'm going to open the solution. Let's see, check out, and I'm going to run the installation again. Also re-import everything. Let's see what happens there. Yeah. So so we had most, so the application is not that much different. We just added a command line runner that handles the arguments, but I could have done without. I did that only because we were using a bit of a Spring Boot library for doing the validation for us. So it's going to do some auto-wiring underwater to do the validation when you are giving the file for to be read. So yeah, the person class, which is our model, was really big, and now it's much smaller. And instead of writing the if-else statements and the throwing exceptions, we are doing it differently now. To check if the name is not empty, we are using a standard Jakarta validation annotation constraint, and we do that also for the date. We are doing actually even more. We're checking now if the date format is valid and not only empty. And we are going to check that the hair color is not empty. So in comparison to what it was, it has no complexity now, because all the complexity has been abstracted away inside these annotations. So the toString that we used to have is now just an annotation instead of a method. If you would put those two classes beside each other, how it was and how it is, you would quickly see the difference. So we're going to compare with the solution with the original class. So we went from this on the left side. Going to make it a bit bigger. We went from this, a lot of boilerplate and a lot of checking, to this. Neat, right? So yes, it is. All the work is still being done. It's just you're not the one doing it. So this is like one class. The other class that we used is the CSV service, and let's go through it for a bit. So instead of going with try to read the file and throw this or check that, no, we're just going to start up a reader. This is the same list, the person's list, the empty one, and we're going to try to fill it up later. But instead of going to do all the checks by ourselves, we're going doing all the checks and the reading by ourselves. We're gonna let the framework do it for us. We just configure the framework. So here's what we do. We would say, oh well, create a comma separated value to bean class, which is provided by the library, for the type person, and we're gonna do it here. Like give it the file, so it will set up the reader for us, and it will do that here. We will do that here. We're configuring the bean. So we'll tell it, okay, well, here's a reader, here's a buffered reader, here's a file reader, and put them all together, use them. And we're gonna tell it that, okay, mapping strategy. If you remember how it was before, we used to have a line counter that skips the header line, which is actually a pity, because the header line is actually quite useful. See, when you have a header, you know what column, what field it should be mapped to in the model of a person, like the name or the birth date or the hair color column should be mapped to corresponding fields inside the object, which this strategy will do for us automatically out of the box. So we're going to give it that strategy, give it the correct kind of object that it should map to, and voila, we are going to put all this configuration inside the CSV2Bean object, and Bob's your uncle. Funny. No, in this case, Safe is your uncle, and we have created a CSV bean that will do the work for us. We will ask it to give us an iterator, and we're going to iterate over the lines by telling, okay, does the person iterator has next? Okay, it's going every time it has a new line, it's going to map it for us and give us the next person like this. We're going to add the persons inside this iterator to the person list, and we're done. So if you would compare this class to what it was before, let's see, get compare with branch, and we'll take the example then. Oh, escape. I might have renamed the file, because it used to be called CSV person CSV servers. So I'm not very easily able to show you the comparison. I can go back in a bit to the other branch and show you the file as just as well. Actually, we could do a complete comparison, and then I am able to do so. Git compare with a branch, and yes, this one. So here we had the CSV service, which had this really ugly code with a lot of work that you are doing yourself, and also abstracting the information away in a line mapper that we no longer use. So the line mapper that was mapping everything without knowing if the column header had changed. It was a fixed kind of header. It was a fixed kind of position inside the columns that decided if it's a name, birth date, or hair color. So we have less code, but we still have the same functionality. That's what we achieved. The complexity is lower than it was before. It is a bit more readable code, and we are not reinventing the wheel. It's easier to read, yes. The one thing that you do need to invest is some time to read the documentation to figure out which classes to use inside these libraries. So I have used Lombok for the boilerplate. I have used the Spring Boot application for auto wiring. I have used the validation framework from Jakarta with its constraints. So there's quite a bit happening underwater, and that will need some investment on your part as a developer to get to know these frameworks. What it will save you in the long run, though, is that you can just reuse that code again and again in different projects. This knowledge is not wasted knowledge, and if you make the code in the example that we started with, you will have to write the code every time from scratch. So it will give you more time, more grief. It will make your code guaranteedly uglier. So I do like this approach. Unless you're writing code for embedded systems and you have no memory and you have no processing power, then there are reasons why you should write the code every time and make it smarter and really exactly just enough. But most of the time we don't. right? We're working for other companies creating day-to-day applications that change, and the flexibility that frameworks offer and libraries should not be ignored and should be really considered. If you're going to add value to your customer by not reinventing the wheel and not writing code, writing less code, then you actually are doing them a favor, and you're doing yourself a favor and your colleagues. So, on that note, I hope this was helpful. This was a helpful demonstration of what you could do. And yeah, I'm going to focus next time on the why. Why am I doing this, and why am I showing you how to reduce complexity and how to do it? And it's actually a part of a bigger agenda that really interests me, and this is the maintainability of code. And the maintainability of code is a theme that really does interest me, and this complexity is just a part of it. So if you're interested in the next session, like why were we doing this, and then I'm going to talk about the ISO 25010, and I'm going to focus on a part of it, which is maintainability. So code quality really depends on so many things. If you start with all the things, you will get lost. But if you take step by step, like complexity, unit testing, coupling, cohesion, and the other parts, like step by step, understanding what makes code good code, or what makes code difficult code, then I think that's something that we should all strive for as developers. And I have noticed that in the past years, a lot of companies are just like using developers as disposable objects, which we are not. And because they don't know how to appreciate what we can do for them, and we are very bad at communicating that to them. So new developers are creating a lot of code really quickly and getting into the same problems that you would not have if you knew a thing or two about maintainability and what it means. Then you would be creating code that would not that would pave the way for you to grow, for the companies to have added value, and to actually have more fun in what you're doing. So I don't know what the I remember one company was calling developers, well, your conveyor belt workers. That means like something comes on the conveyor belt, you pick it up, you do your trick, and you put it back, and the next person does something else, which is very weird. It's not. We're not, right. We're not conveyor belt people. We're just being used sometimes in that manner because code is being used in that manner as well. And often because it becomes too complex. The code becomes more complex if you write it really quickly without using all the tools and strategies at your disposal. And if you don't know these strategies and you're under time constraints and people are pressuring you, then it's good to know what to do, right? So next time we're going to talk about the ISO 25010, what it can do for you if you use it correctly and understand what's in it. And I hope to add value to you, my dear colleagues, because I love you guys. And yeah, let's do more of these knowledge sharing. I hope that other people do that as well. And if I'm not doing a good job, please let me know. All the feedback is welcome, and it would increase the chance that my knowledge sharing would become better. So thank you for your time. I hope you enjoyed the session and have fun until the next time. And to my daughters, see, I still have it. Bye.